Welcome back to the Explainer. So let's just jump right in. For the last couple of decades, the playbook for home energy independence has been pretty well predictable. You slap some solar panels on your roof, wire them up to one giant battery box in the garage, and kind of hope for the best. But as we've been digging into the latest research, we found a totally fascinating shift. Honestly, that old monolithic battery paradigm, it's basically dead. What we're seeing today is this massive, quiet revolution in energy storage. We're moving away from relying on just one vulnerable do-it-all box, and instead, we're building these highly sophisticated, systems-based off-grid ecosystems. It's really cool stuff. Now, what's really interesting about this slide is that 71% figure right there. In a typical family home, thermal loads, and by that I mean space heating and your domestic hot water, they eat up a massive, massive chunk of total household energy consumption. Think about that. Only 29% is left for everything else. Your lights, appliances, electronics, the whole shebang. Which naturally leads us to a pretty important question. Why on earth are we using highly refined, super fragile chemical batteries to do heavy brute force thermal work? When winter hits and your solar production tanks, dumping precious electricity from an incredibly expensive lithium battery bank straight into a basic resistive space heater, it's just an absolute mechanical tragedy. It'll drain your reserves almost instantly and leave you completely vulnerable. Which brings us to our first main point, Section 1, the paradigm shift, moving beyond the monolithic battery. So the crucial point here is that true independence requires a totally different mindset. The old paradigm was all about those blue silicon rectangles feeding a single generalized lithium box. And the problem? That setup leaves you completely grid dependent the second your thermal loads spike. The new paradigm, though, is a systems-based approach. It's literally about matching the exact right type of storage to the exact right job in the house. We're now capturing, storing, and deploying power and heat across totally different decentralized mediums based on efficiency, physical footprint, and of course, your own precise household loads. All right, let's break this down further in Section 2, the thermal equation, capturing heat. Enter the Batsand system. This is amazing. It essentially turns the actual earth beneath your feet into an indestructible thermal fortress. Here's how it works. When your solar setup produces excess energy in the summer, highly efficient resistive heaters capture that power, superheat ambient air to an absolutely blistering 930 degrees Fahrenheit, and then blow it into heavily insulated stainless steel tubes. And these tubes, they're buried in a massive container of silica sand right in your backyard. Unlike volatile lithium that degrades a little bit with every single cycle, sand doesn't lose capacity. And obviously, it's definitely not going to catch fire. For somewhere around $7,000 to $20,000, this system completely replaces a fossil fuel-dependent gas furnace. It's like having a massive, zero-maintenance geothermal battery right under your lawn. Okay, but what about domestic hot water? To solve that piece of the puzzle, we really have to embrace the concept of latent heat. Imagine an ice cube melting. It's absorbing an immense amount of energy to change its physical state, from a solid to a liquid, right? But it does all that without raising its internal temperature a single degree. All the energy is used purely to break those internal crystalline molecular bonds. When we actually compare these two methods side by side, the difference is literally night and day. An archaic 50-gallon hot water tank is essentially just a giant utility closet monster. It's constantly bleeding sensible heat into your house while frankly breeding bacteria and stagnant water. Contrast that with latent heat technology, specifically looking at the Sunamp Thermino cabinet here. It uses non-toxic salt hydrates, basically phase change materials, to store the exact same amount of thermal energy as a bulky 53-gallon cylinder. But here's the kicker. It does it in a sleek cabinet that's 4 times smaller. For around $4,300, it flash heats fresh, cold water instantly on demand. It perfectly eliminates those bacterial risks and completely avoids massive plumbing overhauls. And to unlock its true off-grid superpower, you pair it with a smart diverter, something like the My Energy Eddy. This brilliant little electronic brain monitors your home's main panel an incredible 100 times per second. Literally, the exact fraction of a second you start producing excess solar AC power, it intercepts those stray watts and funnels them straight into the Sunamp heater. With this kind of integration, you can supply up to 63% of your annual hot water directly from free sunshine. It's an absolute game changer. Now that we've conquered the thermal load, let's shift gears to Section 3, the electrical fortress, rethinking raw storage. Because as we dug into the research for this explainer, we kept hitting a hidden wall with standard storage, chemical degradation. You see, standard lithium batteries suffer from physical fatigue. Every single time you cycle them, it forces lithium ions to squeeze into a solid lattice structure. Over time, that constant squeezing causes microscopic cracking and eventually capacity fade. So if you're running a high-draw homestead or say you're charging EVs every day, those chemical batteries are just going to quickly destroy themselves. And this brilliantly illustrates the ultimate solution to that exact physical fatigue, graphene supercapacitors. When we look at this comparison, it's pretty striking. Standard lithium relies on destructive electrochemical reactions, which severely limits how deeply you can discharge it before rapid aging sets in. But graphene supercapacitors, they store energy electrostatically. Because there is virtually zero chemical wear and tear, you can safely drain these units down to a 99% depth of discharge with absolutely no mechanical damage. That unlocks a staggering 20,000 cycle lifespan. To put that into perspective, you could drain it empty every single day for over 54 years. For sure, no way standard lithium is doing that. Companies like Supercap Energy have managed to package this tech into what are essentially indestructible residential sentinels. Their sleek 5.5 and 15 kilowatt-hour wall mounts operate flawlessly in extreme temperatures. We're talking anywhere from -4 to 140 degrees Fahrenheit. Plus, there is zero thermal runaway risk and absolutely no need for those energy-draining internal heating or cooling systems. Honestly, this is a system that will genuinely outlive the solar panels sitting on your roof. Which naturally brings us to Section 4, Shifting Chemistry, the Commercial Disruption. Just take a quick look at this number, $300. For years, the biggest vulnerability to true energy independence was the fragile global supply chain of lithium. It's a constrained material, and its price has wildly spiked, peaking at a violent $80,000 per ton at times. But sodium, that's derived from basic soda ash. It is 1,000 times more abundant, it's domestically sourced, and its cost is fiercely stable at an incredibly modest $300 per ton. The contrast there is just amazing. And thanks to industry giants like CATL, sodium-ion batteries are now commercially available right off the shelf. And they come with some incredible superpowers. See, because sodium doesn't violently alloy with aluminum at low voltages the way lithium does, CATL can use cheap, lightweight aluminum current collectors. That specific tweak unlocks true zero-volt discharge capability, meaning you can completely drain it down to absolute zero without ruining the chemistry, which, by the way, would instantly kill a normal battery. Plus, it happily survives harsh winters using purely passive ambient air cooling, which cuts out parasitic power drain by up to 90%. Now, while sodium-ion absolutely represents commercial affordability, when we're talking about pure raw muscle, we have to turn to lithium iron phosphate, or LFP. While looking through the sources, we found a quote that just perfectly hits the nail on the head, calling LFP the undisputed heavyweight foundation of the residential off-grid world. The reason is, if you have massive instantaneous loads, think heavy AC compressors or a deep well pump kicking on, you need this specific chemistry. Old lithium used volatile conflict minerals like cobalt and carried a really high thermal runaway risk. But LFP, it utilizes an olivine crystal structure. Think of it like a microscopic armor shield. The chemical bonds are so incredibly strong that the battery flat out refuses to release oxygen even under extreme abuse. That completely eliminates catastrophic fire risks inside the home. It's a huge peace of mind upgrade. So let's move on and see how this builds into an actual physical hardware setup. If you want true off-grid freedom, a decoupled modular system like the ones from EG4 is really unmatched. Let's walk through this step by step. First, you install their heavy-duty centralized 18 kilowatt hybrid inverter. Then, instead of being trapped in some expensive proprietary walled garden, you can incrementally add modular 14.3 kilowatt-hour server rack blocks whenever your demands grow. Finally, you hammer power back into those banks using their 3 maximum power point tracking controllers. This kind of architecture gives you total structural freedom and a ridiculous lifetime cost of just about 7.5 cents per kilowatt-hour. Okay, let's bring it all together now in Section 5, the modern energy ecosystem, true sovereignty. Well, we've definitely covered a lot of ground today, but as you'll see, the pursuit of energy independence is clearly no longer just about hanging a single backup box on the wall and crossing your fingers. It's really become a highly sophisticated choreography of advanced physics and thermodynamics. By decentralizing your loads, using sand for space heating, salt hydrates for hot water, supercapacitors for daily deep cycling, and advanced LFP or sodium chemistry for the raw heavy lifting, you aren't just creating a backup system, you are building a permanent, absolute replacement for the vulnerable utility grid. It's like a giant puzzle coming together perfectly. So I'll leave you with this final thought. The off-the-shelf technology you need to declare your total energy sovereignty, it's already here. So what does this all mean for you? Are you ready to stop renting your life from the centralized utility grid? Let that sink in. Thanks for joining me on this explainer, and we'll catch you next time.